Hi, welcome to clickmeproject.com. Now we are going to see the title of Improving MapReduce Performance Using a Smart Speculative Execution Strategy. In this, we are going to see how a pitfall occurs in a normal Hadoop system and how we are going to overcome that pitfalls. Here, when a pitfall occurs, there is a two things will be happen. One is job execution time reduction and cluster throughput will be reduced. Then this is the serious impacted for struggler the machine. Because of this, when we are going to execute a process, then we are going to fix the time for complete the execution. Here the pitfalls occurs, then long time take to finish the process. This is the problem which we are going to deal in this process. For this, we are going to identify three things when some pitfalls occurs. Use the average progress rate to identify the slow task in the reality progress, and cannot appropriately handle the situation when there exists data queues among the tasks, and do not consider that the backup task finish earlier when choosing the backup work nodes. In these three cases, we are going to choose the efficient VM, and based upon the VM's speed in MIPS, by that the MIPS only we are going to divide the packet size. If the MIPS gets reduces means then the packet size will be automatically reduces. If the MIPS increases means then the packet will be already automatically increased. In existing, there is a only problem which has the standard execution time and standard data transfer packet. For this, we are going to using the two technical processes. One is MCP and EWMA to reduce the pitfalls occurred in a Hadoop VM and reduce the three criteria which we are seen in before. Here we are going to see the data for the process. Here the user will choose the n number of inputs given to the Hadoop VM, which is the called as task. Here this is the Hadoop server which we are going to execute the each and every task which is given by the user and execute in a Hadoop VM, and then result will be given to the user as well as the input. Here the MapReduce algorithm is a normal Hadoop based task which can split the task into two, and a map will do a same process and reduce process will do a some process. Before allocating the task to the VM, we are going to execute our two algorithms which we are going to check whether the pitfalls is occurred or not, or slow task is occurred or not. The MCP is used to find the pitfalls occurred in a VMs or not, and EWMA is used to check whether the slow task is present in the VM or not. If the performance of the VM gets reduced, then the packet size will be automatically reduced by the EWMA algorithm. Here the cluster computer is used to execute the data, and data will be stored into the DB and execute this result that gathered from the DB, and the output will be executed data will be given to the user, which is the output for the process. Now we are going to see the execution procedure for this process. First of all, we need to start the VM, and then you need to enter this query which is execute the sample program for in Hadoop, and by executing that we are getting the output of the process present in the VM. By at the time of execution, we are getting the data of MIPS and the CPI, CPU, RAM, everything the things we needed gathered from the Hadoop. This is the first step in executing the process. While executing this will take some more time to execute, because it will check the entire data to execute the Hadoop, and we are doing the pi calculation which take some more time to execute. After the execution of VM, we are come back to the Eclipse, and then I click the rollclack.java and click run file. This will get executed. At the time I am going to enter the number of files I am going to choose, that is the job for the VM, and click browse button, and I am going to choose the txt file which is going to execute in the VM. Here the first VM job was this file, and then the second will be ask. Here we are going to enter the second file to execute in the VM. This is the only file we need to give the text file alone, not the any other files. Then click the second text file and click upload here, and here will shows the size and path for the each and every file. Then click next button, then click start server, then a message box will be shown as detail quoted. Click OK and show details. This is the detail which is present in the Hadoop VMs. Here the CPI is the number of cycle per instruction, and which is the VM ID, and what is the name node ID, and RAM for the each VM, and bandwidth for the each VM. These are the things we have got it from the Hadoop. After that, click calculate MAPS. At the time the VM 0's MAPS was this, and VM 3 MAPS was this. We are going to calculate the MAPS by using a formula. Then click calculate data, and the MAPS is also calculated for the data also. Get detail. Here this is the size of the each and every file, and get MAPS, and this is my MAPS to execute the file. Then click next data, then click get detail. Here both the VM and the data file will be covered here, and the click allocate button, then this will be allocated to the, and data file 0 is allocated to the VM2, and data 1 is allocated to the VM4. Then remaining 3 VMs is still remaining ideal. While choosing the more than one files, it will be automatically allocated to the next files. Then click next button here, then get Hadoop status and click do process. It will take some more time to execute in this, and then click show result. This is the result we got it from the Hadoop. Here the pitfalls is occurred when the slow tasks occur. The VM2 has the packet 0 and size was 35 KB. Then VM2 MAPS was 3500 at the time T0. At the time T2, the VM2 has a packet 1 and size was 35, and VM2 MAPS was 3500. At the T3 time T4, everything is same. When the time T5, the VM packet size was 40 KB and the MAPS was 4000. Here the not a pitfall, but the data will be changed. At the time no problem. At the time T10, the pitfall occurs, the slow task occurs. Here the MAPS was 2500, in the previous MAPS was 4000, and the packet will be size of 25 KB. Here is the pitfalls rates, and click the pitfalls button to get the pitfalls details, where and which time the pitfalls will be occurred in that process. And click get graph. Here we are going to show the execution time strategy which is present in the both existing system and the proposed system. Here time to execute this is greater than 15,000, because of the pitfalls nodes will be execute once time. Here that node will be taken. The accuracy was high in our system, as well as the pitfalls rate is high in the existing system, and on the proposed system it will be reducing. This is our process we are going to show. Thanks for watching this video.